In this movie, we will discuss hypothesis testing for one sample. We'll start by introducing what is hypothesis testing and how do we formulate hypotheses. And then we will later on develop the methods to test these hypotheses. Why hypothesis testing? A main feature of inferential statistics that we are covering now is to ask questions of the population parameter. Specifically, we will work with the population mean and the population proportion P. So we will ask questions of what might be the value of these given our sample. So again, we do not have access to the population parameters. So we are conducting tests from the sample statistic, whether it's sample mean or sample proportion, to draw conclusions about the population mean or the population proportion. So this process that is used to make decisions about claims from the data by evaluating two competing statements is called hypothesis testing. These competing statements are denoted by H0 or null hypothesis. This is the tentative assumption we make about the population parameter. And the alternative hypothesis is the opposite of what is stated in the null hypothesis. So the key question though is, how do we formulate these two alternatives? How do we formulate the null hypothesis, H0, and how do we formulate the alternative hypothesis, or HA? And the key thing to note is that this is given by the context of the problem. So there are two approaches in formulating these hypotheses. In the first approach, suppose we want to verify a claim about the population. We let that claim be the status quo, that this is the way things are. And if our evidence suggests otherwise, then we will take action to what the evidence is pointing us to. In this case, we can say that the null hypothesis denotes the conjecture or the status quo. So here we will start by casting the claim that we have or the conjecture that we have as the null hypothesis. So think of it as giving the one who holds the claim the benefit of doubt. And then the alternative would be the opposite of that. Now, in most business cases, we are conducting hypothesis testing when we have come up with a new process, a new method, or a new idea, which improves something that we were doing before. So in that case, our claim could be that this new process that we've come up with, this new method that we have come up with of production, or this new way to incentivize people, for example, we have come up with, is doing something better than what was done before. So in that case, we actually are very conservative. We say that maybe this claim did not do as well. So the evidence of what we want to show will be cast out as the alternative hypothesis. So our null will be that this claim is not any good. Things are the way they were. And the alternative would be that things are strictly better. And we will work with some examples to see how we cast this null and alternative. But if there's a research question we are working with, we will let the finding that we hope to see as the alternative hypothesis. And then the opposite becomes the null. So in terms of carrying out the test, we can have three kinds of tests. And these tests are determined by the statement of our alternative. The left tail test is when we assume that our population parameter, in this case the population mean, is more than or equal to a postulated value. And then the alternative is that it is strictly less than that. Notice that our alternatives have strict inequalities. And the nulls have the equality sign in them. And then the direction of the test is given by the direction of the alternative. Here the alternative is pointing towards the left, so we call it the left tail test. On the other hand, right tail test is when Our null hypothesis is that the population value or the population mean is less than or equal to our stipulated population mean. Mu naught is the conjecture, the value that we hold the population to take. And the alternative then is that our population is actually more than our postulated population mean. So here, the arrow of the alternative is pointing to the right, so this will be a right-tailed test. And then the two-tailed test is when we have an equality. In the two-tailed test, the alternative has an equality, and the null then has an inequality. So again, it is important to note that the direction of the test is given by the direction to which the arrow, so to say, in the alternative is pointing. This would be an example of a left-tailed test. This is an example of a right-tailed test, and this is an example of a two-tailed test. If we find the evidence supporting the alternative, we reject the null. Otherwise, we do not reject the null. And again, we'll develop these ideas of how do you find evidence, what do you mean by rejecting or not rejecting the null, at what level. Now, because we are making a claim about the population parameter, whether it's population mean or population proportion, when we conduct our test, we can have two outcomes. It can be a correct outcome or it can be an incorrect outcome. So let's say that our null hypothesis in the population is true. If our test says that that is true, then it is a correct finding. But our test could also say that the null is false, even though null may be true. This is what we call as the type 1 error. So type 1 error is a probability of rejecting the null when the null may actually be true. So we develop the confidence interval. We call the level of significance as alpha. Alpha really is the probability of the type 1 error, or probability of rejecting the null when the null in fact is true. Now suppose in the population our null is not true. So if the null is not true, if we conclude that the null is not true, that's a correct test. But what if our test concludes that the null cannot be rejected, but the null actually is not true? The alternative is what's true in the population. We call that the type 2 error. So type 2 error is the error of not rejecting or failing to reject the null when the alternative is true. We do not explicitly control this. We will see that we can control the probability of type 1 error by dictating our level of significance to be 10%, 5%, or 1%. But these tests do not typically control the probability of type 2 error. We denote the probability of type 2 error by beta. So beta is the probability of not rejecting the null when the null is actually false or the alternative is true. And 1 minus beta is called the power of the test. This is something that we will take as given. Our testing procedures will essentially focus on the probability of type 1 error by stipulating alpha or level of significance. So let's look at some examples of how do we formulate these hypotheses and what might happen if we have an incorrect claim. In this first problem, the mean entry-level salary of an employee at a company is $58,000. Here, the null is a claim, and we want to test the claim. So we will give the holder of the belief the benefit of doubt. So we would cast our null as mean salary equals $58,000, and the alternative would be that this salary is greater than $58,000 for IT professionals. So this will be a right-tailed test, and of this test would imply that we have enough evidence to say that the mean salary of IT professionals is more than $58,000. If we cannot reject the test, then we say that our sample suggests that there's not enough evidence to believe that the salary of IT professionals is more than $58,000. Let's see how we apply it in the case of a proportion. So in the next one, we're told that the population of female fish in a certain population is 42%, or our P is 0.42. A test is conducted to see if in fact the proportion is less. So again, this is a conjecture. We will work with our claim that the population of female fish is equal to 0.42, and then our alternative is that this is less than 0.42. Now we could have also made our nulls to be including inequality, so I would have said less than or equal to for my first case, and in the second case we would have said more than or equal to. But notice that our alternative is always pointing in one direction. So for our first one, our alternative was mu is strictly greater than 58, because we claim that maybe for IT professionals the starting salary is more than $58,000. And then for the case of the population of female fish, proportion of female fish in this population, our claim we want to conduct if they are less than 0.42. Now those were claims. Now look at this third example. Here we have a current plan in place in an automobile dealership, and right now the mean sales volume by the various dealers is 14 automobiles per month. The manager has come up with a new bonus plan, and she wants to see if this plan will be successful. So because we're implementing a change, here will be a lot more conservative or worry of what our findings might be. So we will play the devil's advocate, so to say. We will play the contrarian. We'll say that maybe this bonus plan will have no effect. We want to hope to find that this bonus plan will actually increase our sales volume. So we will formulate the alternative first. So if I formulate the alternative, I can say that this bonus plan will increase our output. We'll be selling more than 14 cars. But if this bonus plan was ineffective, then we will be selling at most what we did before, but at worst even less. So our null is that our mean sales will be less than or equal to 14, and our alternative is that it will be more than 14. And then the next part says, what is the consequence of a type 1 error? Now type 1 error is probability of rejecting the null when the null in fact may be valid. So in that case, the null says that a bonus plan will not really implement any additional gains in sales, but reject the null saying that the bonus plan is actually worth it. Now the cost would be that we will add more expenses because we're incentivizing more, we are offering more bonuses, but we are not seeing a resulting increase in the output.